The last video was a longer one, dealing with congruency in figures in general. Now we're going to start focusing on individual figures and what we can do with that. So this one is going to be about triangle congruence. And we're going to approach it specifically through two sets. We're going to go SSS and SAS. And I'll label these, anytime we're doing these, the S stands for side and the A stands for angle. So this particular video we're going to focus on triangle congruence featuring three sides or two sides and the angle that's stuck between them. So let's see what this looks like. If I have a triangle like this, and then I have another triangle, these triangles are congruent if every part of them is congruent, is equal. So if I have a triangle here, A, B, C, and here triangle D, E, F, then if these are going to be congruent, then side AB has to be congruent to side DE, side BC is going to be congruent to side EF, side CA is going to be congruent to side FD, and angle A will be congruent to angle D, angle B congruent to angle E, and angle C congruent to angle F. These are all true if triangle ABC is congruent to triangle DEF. In order to show that these are congruent, we can work this thing backwards. We can say, if I know all these things, then these are congruent. I could instead phrase it this way. If this, then this, but also the opposite direction. If all this is true, then they are congruent. I want to see, do I really need all of these pieces of information to get there? And I don't. As it turns out, if just this left side, if just these conditions are met, that's enough. If all the sides of this triangle are congruent to the sides of this triangle, it turns out that that's enough to be able to establish that the triangles themselves are congruent. And once we know that the triangles themselves are congruent, I know that all the angles have to be also. That's called a side-side-side congruence. So side-side-side postulate, if you like. So side-side-side is enough information to tell me that these are congruent to each other. But it's not everything that works that way. Let's say I have less information. Maybe I don't have that all my sides are equal. If I have that all my angles are equal, so angle, 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 is that enough? Well, it's true that all these angles and all these angles are congruent, but it would also be true that all the angles in the triangle on the left are congruent with all the angles in the triangle on the right if I scaled it. All the angles are still congruent, but the sides are not. This is enough for them to be similar triangles, but not enough to be congruent. So angle, angle, angle is not going to cut it. And that's more or less what we're doing. We are trying to figure out what's going to work and what's not. Angle, angle, angle doesn't work. It is enough to say that they're similar, but there can be a scaling factor. Now, if all the angles are congruent, and we know, so if we know all of these, and one of these, any one of these, then we're good to go. Because if we have all the angles, we know that they're similar. If one of the sides is the same and they're similar, they have to be congruent triangles. So angle, angle, side, that's fine. Well, angle, 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 side is fine. But what we did in the last lesson is we saw that if we have two angles of a triangle, if those are congruent to two angles of another triangle, then the thirds have to be congruent to each other also, because all the angles in a triangle have to add up to 180. So having two angles and a side, that's enough information to know. So that will establish that we have congruency. Next thing, side-side angle. If I know this side of this triangle, DE and EF are congruent to AB and BC, is it enough to know that those triangles are congruent? Well, if I've got two sides, that's fine. And then I need the angle to the next part of my triangle. So I want an angle and two sides, and that angle's not the angle that's between them. If I take this side right here, EF, and I instead flip the direction of it, and, move it into place, I still have the same angle here. Angle D is still congruent to angle A. AB is still congruent to DE. And BC is still congruent to EF. F would move over here then. Let's call that thing F prime. So AB is congruent to DE. BC is congruent to EF prime. And angle A is congruent to angle D. So I've got two sides and an angle, or an angle and two sides, whichever way you want to think of that, but the angle's not between them. I can make two different triangles that work that way, so this is not sufficient. Let's go back and fix this. One more combination to try. Let's take a look at side, angle, side. I know the answer because it's right here in the heading, but side, angle, side. I've got AB is congruent to DE, the angle B, that's the next one, is congruent to angle E, and then I've got side BC is congruent to side EF. Well, once I've got those, I've got the start point and the end point. I can only connect those with one line, so then AC will be congruent to DF, which means these triangles have to be congruent. This one works. So I have some conditions that are good, that are completely sufficient to show my triangle congruence. I can side, side, side. I can angle, angle, side, or side, angle, angle if you like. And I can side, angle, side. Those are fine. Also, I could angle, side, angle. That's fine, because again, if I've got two angles, I've got the third. So these three are good, and then I've got a couple that don't work out. These, not so good. And that's enough to show triangle congruence for two triangles based on kind of minimal information. We're only using 3 pieces of information to establish that all 6 are good. I want to do one quick version of what does this look like in an example. Let's say I have these triangles. And maybe I know that these lines are parallel to each other. I'll label some points. A, B, C, D, E. And I know those are parallel to each other. I'm going to need probably one more piece of information. So let's say not only are they parallel, but they are the same length as each other. Can I state that these are congruent triangles? Let's see. I am given that BA is congruent to CD. I am given that BA is parallel to CD. Those are good. I know that angle AEB is congruent to angle CED because those are vertical angles. I know that angle ABE is congruent to angle CDE because of alternate interior angles. I have 2 angles. That's enough. I can say angle BAE is congruent to angle DCE. Because if I know 2 of the angles inside a triangle, I know the third. Via the third angles theorem is what that's usually called. Third angle theorem. Now I know, because all the angles are congruent and the sides are congruent, I can say triangle ABE is congruent to triangle CDE. And I can get there. I've got 2 angles and a side, so that would work. So I took what I was given and made some conclusions, and I have a 2-column proof.